Okay, let's get started. I'm Jan Ozer. Thank you for coming. We've got about 60 minutes for about 70 slides, so I'm going to try and get them through quickly, and hopefully we'll have a little bit of time for questions at the end, but no questions during the presentation. A lot of this material will be familiar to many of you, so hopefully we can get through it pretty quickly. This is part of my debut tour for this book. I've got a limited number of copies available for £20. It's selling for $29 on Amazon now. Anybody wants to pick up the book, just see me after the presentation. So the premises of the talk are producers need to distribute to all available streams to maximize the reach or the profitability of their video. Computers, mobile, and OTT. Most producers at this point are at least thinking about adaptive delivery if they're not already delivering adaptively. So basically what I'm going to try and cover today is how to produce the fewest number of files that allow you to deliver adaptively to those three general platforms. The agenda, there's basically two aspects to this. It's kind of interesting. There's the encoding side, producing the files that you need to produce to get to the targets, and then there's the packaging side. What you're going to use smooth streaming, you're going to use Flash, you're going to use HLS. So there's really two aspects to that, and we're going to cover both. We'll start with H.264 because today H.264 is the only codec you can use to reach all these targets. Spend a little bit of time defining adaptive bitrate delivery. We'll look at the alternatives, and then at the end we'll look at configuring the streams. How many streams, what resolution, what data rate, that kind of stuff. And also, finally, how do you encode those streams differently than you would for single stream delivery? Why H.264? It's the highest quality compression technology generally available today. It plays everywhere. In Flash, QuickTime, and Silverlight, not universal in HTML5, doesn't play in Firefox or Opera natively on Windows XP computers and before, but it does play natively on all mobile devices and all OTT platforms. So H.265 is coming, but H.264 is what you need to use today. Now, you can spend hours trying to come up with the best H.264 encoding parameters to reach all these streams, get the maximum quality, but there's really only two parameters that impact compatibility, right? So compatibility is our first concern. Does it play? Then our next concern is, okay, well, how does it look? So for this talk, I'm going to focus primarily on compatibility because that's the major focus, getting on these three screens. So most critical is the concept of the profile. So every H.264 encoder will let you choose a profile. And we'll look at what a profile is in a second. And this is the major configuration option that determines whether or not you're going to be compatible with the devices that you're targeting. So what is an H.264 profile? There won't be a test on this, but it's important to at least see that there's a bunch of algorithms and encoding tools, and the definition for Wikipedia is, a profile defines a set of encoding tools or algorithms that can be used to generate a bit stream. So here are the encoding tools and algorithms, and here are the main profiles that you're going to be using. So you've got baseline, main, and high. What presumption would we make in terms of quality? Looking at all the algorithms and techniques you can use here, and all the ones you can't use here, what presumption would we make about quality as compared to the high profile versus the baseline? Which would give you better quality? Anybody?
High, go ahead.
High profile. Okay, so we would hope the high profile. What's the general trade-off we would expect from the high profile? Quality never comes without a price. What's the price? Harder to decode. Okay, so the general, the high-level concepts about profiles is this is easier to decode but lower quality, and this is harder to decode but better quality. And that's a very important concept to understand because this profile plays everywhere. And this profile doesn't play on a lot of lower-end mobile devices. So you're going to have to make the decision, do we customize the streams, create two sets of streams, one for mobile, another one for OTT and desktop, which doubles your encoding cost, doubles your storage cost, administrative cost, or can we use one set of streams for all devices? And that's a very fundamental concept we'll be covering in more detail. Why do profiles exist? because it lets hardware manufacturers use H.264 but limit the CPU power necessary to decode the video. So when Apple came out with the first video-capable iPod, they said, we're going to support H.264 video, but only the baseline profile, because that way we can afford the CPU, we can afford the battery life. And if you're a video distributor, you know that to support that device, you need to produce your video using the baseline profile. So it's a nice meeting point between the hardware vendors and the video producers, and that's why profiles exist. So rule number 1 is when you're encoding for multiple screens, don't exceed the profile of the devices that you're targeting. And looking at a couple of groups of devices that we care a lot about, this chart, available for download. People who came in late, the presentation handout is available now on my website at streaminglearningcenter.com. It is the upper left-hand side article. I'll be adding to this as I talk over the couple of days, but this should remain on the first page for the foreseeable future. The fact that that's available for download frees me up to put highly detailed charts in there, because even though you can't take notes on this stuff, you can just download it. But the thing that's interesting here is that if you care about, and a lot of producers just don't care about old iPhone 4s, right? Where anything before iPhone 4, a lot of producers don't care about. But if you do care about them, you've got to encode using the baseline profile. And if you care about iPhone 4, so this is iPhone 3 and earlier, this is iPhone 4 main profile, and iPhone 4S went to the high profile. And then you can see the iPad 1 and 2 main profile. New iPad is the high profile as well. And then the equivalent chart for Android is much more challenging, because Android, of course, has multiple manufacturers, and Apple doesn't. Apple manufactures both the OS and the devices, so they make a very simple chart. And what Google tells you at the URL above is, we don't know what our hardware manufacturers can play. But in software, all of our devices can play the baseline profile using these configurations. So if you want so logically, you would say, okay, all these Android devices probably have the same amount of CPU horsepower as the iOS devices. They probably can play main, they can probably play high. My daughter's phone plays, it's the HTC Rime. It plays high profile pretty well. I've got a couple of Android devices, they play high profile. But if you're telling your boss, or you're encoding your own video for your own site, you know that baseline profile will play, you don't know that high profile will play. So, and this kind of shows you what I talked about a few minutes ago. If you encode your video using the baseline profile, it plays everywhere. If you encode your video using the high profile, you lose pre-iPhone 4, Android 3.0 software. You're not sure about the Android hardware, and you lose the iPhone 1 and through the iPhone 4. So that kind of sets up the big decision. Do you produce one set of files, all baseline, that plays everywhere, which is cheaper and easier? Or do you produce separate files, using the baseline, main, and high profile, separated for your different target platforms? So one consulting project a few months ago, I kind of looked at this question for a client who was converting DVDs over to adaptive streaming files. So they're starting out with SD video, and he basically, so I went through the chart, and he's like, well, how much difference in quality is there? I said, good question. So I ran 3 tests, 720p at 800 kilobits per second, which is a very aggressive test, a very low bit rate. Burberry is at 3 megabits per second, ESPN 2.5 megabits per second, YouTube at that resolution is at 2 megabits per second. Why so aggressive? Because at 3 megabits per second, everything looks good. You're not going to see any difference in quality. So you want to test at the aggressive parameters so you see if there's going to be a difference. 640, 480 at 500 kilobits per second in comparison. CNN with their 640 by 360 stream is at 1.2 megabits per second. Again, a very aggressive test. 640 by 360 at 240 kilobits per second. Very, very, very aggressive encoding, but when you're producing for adaptive streaming, you've got some very low quality streams that play on cellular and low connection speed computers. So this is actually an encoding parameter that was used by one of the 3-letter networks in the US for their lowest quality adaptive bitrate stream. So it's very aggressive, but it's also very realistic. Okay, if you download the handout, you'll see these screens in much better quality. So this is the baseline profile over here, and this is the high profile over here. And the reason I have this particular slide in this presentation, and I use this one a lot, is it's a high motion slide. This skater is just finishing a skating run, but there's a lot of detail. You can see the fence here, the fence back here. So it combines high motion, high detail. It's a very hard to compress frame. Yet we see very little difference between the baseline profile on the left and the high profile on the right. So this was very striking to me, very, very surprising. This is, and you can see, so I produced the client was nice enough to say, I said, do you mind if I publish this stuff on my website? They said, fine. So you can, if you go to this URL, you can see the article that I wrote, you can see the files that I encoded, you can see all the comments that came from a lot of producers, both US and abroad. And so this is baseline, that's main, that's high. And again, this is one of the more challenging sequences because the dancer is dancing across the stage. So it's a very, very full pan sequence, a lot of motion, even though it doesn't look like a lot of motion. Anybody tell the ballet? Anybody out there? It's Capellia, which is a wonderful ballet. This is my daughter, now 15. Okay, so again, more to the point, we just see very, very little difference between, and I encourage you to download the slides, I'm sure you will, because you'll begin to look at it on your screen, not on this screen here, but you will see very little difference. And then this is the most aggressive, encoding configuration. This is 640 by 360. This is the high profile. This is the baseline profile. And here in the window screen, we start to see some loss of detail in the baseline profile up here that we don't see in the high profile. So here realistically, you could say the high profile produced a noticeably higher quality stream. So, but looking at the other two encoding examples, we see very little difference. So I guess the bottom line for me is don't assume that all those encoding algorithms and techniques on the left-hand side of that column that we looked at produce substantially better quality. You're going to have to make a decision. You can support OTT, mobile, and computers with as few as 7 or 8 streams, or you can say, well, let's customize, and you're going to create 16 streams or 25 streams, all of which cost you encoding time, storage cost, administration. So don't assume there's a huge difference between the high profile and the baseline profile. Come up with your sets of streams, compare the tests, and then see if there's a big enough difference to encode separately. We're going to look at what a lot of the people do in the United States. Turner Broadcasting ignores my advice, and they produce separate streams for all the targets. And most big companies do the same. I'm not sure they're getting any return on that, but that's the decision that we'll look at in a few minutes. Okay, so we talked about profiles. What are levels? Levels constrain key parameters in the bit stream. So, if you're level 1.2 in the baseline profile, you can't exceed 384 kilobits per second. If you're encoding for mobile devices, you care about levels. If you're encoding for computers and OTT, you do not, so they're not a concern. And a lot of this will come together towards the end of the class when we look at the configurations for all these targets. But again, the thing you really need to worry about for compatibility is the profile, and then level is kind of a subset of that. Okay, any questions on anything so far? We're doing okay time-wise. Anything? Okay. No questions about my book? Any? Okay, so let's look at adaptive streaming. So we like adaptive streaming. Let's see what it is and how we can produce for it. Adaptive streaming is one stream in. This can be live. This can be video on demand. And then the streams are switched transparently. And by transparently, everybody's watched YouTube. You can control the quality of the stream by that little icon on the bottom. You can choose high, HD, 720p. But that's adaptive streaming is all transparently. The user clicks on one button, and the stream switching occurs in the background. And you have this is a digital rapid slide. You've got one stream going in. This one, you've got, in this case, 3 streams coming out. This is a high-quality stream for good bandwidth, good playback conditions, lower quality and less quality for mobile. 1 stream in, multiple streams out, switched adaptively and transparently to the viewer. By adaptively, I mean if the delivery bandwidth changes, the quality will drop. If CPU utilization starts to increase to 99% or higher, then a lower quality stream that's easier to decode will start to come in. So those are the variables that are looked at in the transparent switching. So what's the key benefit? You match the quality to the playback platform and the connection speed of the viewer. So if you've got somebody with the average connection speed in Europe is probably 4, 5, 6 megabits per second. If you've got somebody with a 15 megabit per second account and they've got a big screen TV they're feeding with a Roku box or with an Apple TV, you give them a very, very high quality experience while still serving the mobile customer. So adaptive streaming frees you to give a very high quality stream to people who have powerful computers on fast connections because you can still support mobile connections with a lower quality stream. And there's 2 types of systems. There's server-based technology, and I guess the primary example for that is Flash and Rtmp streaming. And then there are multiple HTTP-based technologies, and we'll look at what that means in a second. Probably the most used is HTTP live streaming, HLS, that's Apple's technology. Smooth streaming from Microsoft. HTTP-based dynamic streaming from Adobe, that's HDS, and that's a successor to the Rtmp-based streaming, and then the new standard dynamic adaptive streaming over HTTP, or Dash.
Yeah, just one connection. Do you know anybody who's actually using Dash?
We're gonna cover that.
Okay. Sorry.
No, it's okay. It's okay. So how does Rtmp Flash? I'm sorry. How does Rtmp Flash work? It uses standard MP4 or F4V files. There's no chunking. There's no manifest files. It's your basic encoded file. There's a persistent connection between the player and the server. So you need a Flash media server, a WowZa media server, any Rtmp-capable server. You need one of them, and you need a consistent connection with each player. The player monitors the buffer and the CPU utilization we talked about before. And then the player says, I'm in trouble. I need a lower quality stream, or life is good. I need a higher quality stream. And it requests that from the server, and then the server sends the stream. So persistent connection, communication between the player and the server, and that's how it worked. What do we not like about Rtmp? A server is required. So what does that mean? People like to get paid for their servers, so that usually can increase the cost, and it may limit scalability because every server will have just a limited number of clients that it can communicate with. Rtmp packets can get blocked by firewalls. Rtmp packets don't take advantage of HTTP caching mechanisms, which is less efficient for some popular videos. And some CDNs are dropping support for Rtmp in the US. Is that happening here in Europe? Anybody seeing that? Okay, I mean, it's Highwinds is the one in the US that's most known for that. But I think more of that is going to be coming. In contrast, HTTP-based technologies, they don't require a streaming server. So in theory, they should be lower cost because, again, servers cost money. You don't need a server for a streaming server. Obviously, you need a web server, but not a streaming server. So better scalability, lower cost, ubiquitous support among CDNs. And because they use HTTP protocol instead of Rtmp, which is proprietary for Adobe, there's no firewall issues, and it can use standard HTTP caching structures. So there are a lot of companies in the United States. So the big rap against Rtmp is firewall problems and scalability problems and cost problems. But if you look at it, the Wall Street Journal uses Rtmp-based streaming. TheStreet.com, which is an investment site, uses Rtmp-based streaming. So if there were massive firewall issues with corporate clients, they wouldn't use that. They would have jumped to HDS as soon as it was available. So I think a lot of the problems are kind of more fluff than real. But if I was talking to a client today, I would say if you're going to start implementing Flash-based adaptive streaming, I would use HDS. Would I drop Rtmp tomorrow? Probably not, if it's still working. But clearly the future is HTTP, but Rtmp is a very, very viable technology, and it's still being used by a lot of producers, both in the US and in Europe. Okay, so that was Rtmp. Rtmp is the persistent connection between server and player. And this is how HTTP-based streaming technologies work. And the encoder creates chunked video files, and those are these little segments you see up there, and it creates an index file. And this is, again, HTTP, this is HLS. And it sends the video files and the index file to the server, to the web server. And then the player retrieves the index file, monitors the buffer, and then changes streams as necessary. And let's take a closer look at that. So the M3U8 contains links to index files for each of the files in the adaptive group. So if I'm the player, I check this file, and that tells me, okay, there's the address for the index file for the low quality, for the mid quality, and for the high quality. And then within these text files, these index files, there are addresses for the different chunked video files. So the player is in charge of everything. There is no server component. The player starts out playing, and you get to set which stream they view first. So if you're conservative and you want the video to start streaming quickly, you might say, let's start with the lowest quality stream. So you start with the lowest quality stream. The player checks this index file, gets sent to that index file, and gets the URL of low01.ts. So the player's doing everything. It's checking these files on the web server. And then the player says, well, bandwidth is good, CPU utilization is good, let's try a higher quality file. It goes back to this file and says, where's the higher quality file? It gets this address, and then it retrieves this file. So the player is in charge of figuring out where the files are using this index file system and retrieving the file chunks as necessary. So that's how HTTP-based technologies all work. It's a very elegant, very simple solution that eliminates the server component. And again, they all work the same way. They create the chunk data files, they create the index files, which are called manifest files. These are placed on the HTTP server. In a live scenario, the chunked video files are updated continuously, and the index files are updated continuously. So this can work for both video on demand and for live. And the player monitors the buffer, sometimes CPU use. I say this because Apple devices only care about the buffer. They don't monitor CPU utilization. Most of the other technologies monitor CPU and buffer. The player changes streams as necessary using the index files to find the correct files. Okay, so Adobe HTTP dynamic streaming. You've got your media file chunks, the F4F files, and you've got your manifest file. So it's player-driven system. The player monitors CPU and buffer conditions, and then retrieves the different streams as necessary. Smooth streaming, same thing. You've got your manifest file here, your chunk video files here, and the player does all the work. And then Dash, dynamic streaming over HTTP, uses the same schema. So you've got your fragmented video chunks, your manifest files, and it's a standard that's got multiple codecs, container formats, and manifest file formats. Very flexible standard, which has been one of the problems. So your question, where's Flash today? Flash, so in terms of native support, when I say native, I mean you don't have to buy a plugin, you don't have to do anything but make your video available. What's supported natively in the platforms you care about? Well, it's not in Flash, but it will be in Primetime, which is Adobe announced the Primetime platform a few months ago. It's a platform you pay for. It's not native, but it will be available in Primetime. It's not available in the iOS platform. To my knowledge, Apple has made no comment about whether it will. in the short term or ever. It's not available on the Android platform natively. As far as I know, there's been no official word from Google as to when or if it will be available on Android. It's not in Firefox. There's word on the street that Microsoft and Google are working to add Dash support to Chrome and Internet Explorer, but there's nothing from Mozilla, and there's no official word from Safari. A lot of talk here about the H.264 only subspec. There will be sessions on that later in a couple of days. If you're interested, you should go check those out. And there is still a potential royalty issue. We asked when Adobe announced Primetime, one of the questions I asked them was, do we know if Dash support will incur a royalty? Because there is proprietary IP included in the Dash spec. And they said, we don't know. So, Mozilla is never going to support something, and I don't want to say never because, they may decide that they have to remain viable, but, the whole royalty issue, until that gets settled, it's tough to see a lot of this getting settled because there could be big money there. Now, we're going to talk about third-party libraries or products like Adobe Primetime that allow you to use Dash today, but in terms of native support, there's really nothing out there. So if you're looking to use Dash today, it's just not there.
I put a flag on Chrome quite recently, and it will play Dash natively in JavaScript.
Okay.
You have to turn the flags on in Chrome.
Okay.
Chrome://flags.
Okay.
You can turn on MSE, and it will play natively.
Okay, good. Thank you for bringing that up. So apparently there's a flag you can use in Chrome to play back Dash. One would ask the question, which Dash? Because the thing about any kind of new standard like Dash is there's going to be a bunch of interoperability problems. Because Squeeze can put out Dash encoded files. A lot of the vendors in there, I know that Telstream has it, I know that Thomson has it, but have they tested those streams on the Chrome implementation? Yes, no. Until all that settles out, it's going to be challenging to, and even, Chrome is 22% of the market now. So Chrome has it, that's great, it's a start, but Internet Explorer is probably 60% of the market, and maybe 75% of that number is IE 8 and 7, which will never be HTML5 compatible. So it's tough to see where browser support is going to lead the charge to Dash because that market is just so fractured today. Again, there's going to be multiple sessions on Dash that are going to go into it a lot more than I will. I'm not a big proponent of Dash because for me, until I know what Google is going to do on Android and what Apple is going to do on HLS, it's just another format. It's not a universal standard that everybody supports. It's just another, maybe it replaces Flash, but it doesn't get me on Apple, and I care a lot about getting on Apple. Okay, so let's look at another alternative. HLS, as we'll see, plays on all OTT devices. It plays, obviously, on all iOS devices, and it plays poorly on Android devices. So HLS is a pretty universal format at this point, and there are several prefab video players like the JW Player that add HLS support. So what is it? JW Player is a player that you buy to integrate into your website so you don't have to build the Flash player. You can build it yourself or you can buy that, and that gives you certain features that you can just plug in and use. A nice time saver and pretty inexpensive. Now, if you buy the JW Player today and you integrate that into your website, you can send HLS streams to your website and they will play. Okay, so if we're looking for a universal format that plays everywhere, HLS, if you use the JW Player or other players that provide the same feature, gives you HLS support for any Flash, any browser that's got Flash installed can play HLS. Of course, it plays on the iOS device, plays poorly again on Android, and plays on all OTT devices. So today, as opposed to Dash, which we're now hearing plays with a certain flag on one browser, that's, today you can get HLS pretty much everywhere. And I think if I'm looking at supporting one technology that's, that's native support, So I don't have to create an app for it. It's native support. HLS seems like a lot better choice in the short term than Dash does.
How do you spell
JW Play is on Android. So,
And we'll look at that.
they publicly state on the website.
Yeah, oh yeah. We'll see a reference to that article in a few
Is
seconds.
there any difference with HLS working on, let's say, with Flash? Does it work as well as on iOS?
Is anybody using that solution?
Yeah, that's fine.
No, I'm asking. I'm not aware of any.
Yeah, 'cause it's-
So I just wanted to know if anybody else.
I think there are small differences, but for instance, when you seek within like HLS stream on native in HTML5, you can also seek within like a chunk.
Yeah.
But for instance, with the latest DW, it's not possible to only seek to the nearest start of a chunk. So for instance, if you have a chunk size of 8 seconds and people
You
want
can
to
only
seek
see-
to 2 seconds within the chunk, then you have a small offset.
Yeah.
But other than that, I think most, and there are a little bit more stricter encoding recommendations for
Is that all?
DW play.
Because I know OSMF framework has HLS plugin.
Yeah.
I was wondering how is that working, if people are actually using it.
Well, it's interesting that Adobe with Primetime. So Primetime is Adobe's solution to integrate a lot of their different monetization products, information products, and playback products in one platform. And they recognized that Flash wasn't going to do it because Flash doesn't play everywhere, doesn't play on a lot of OTT platforms. So what they did is first they announced in April that they're going to have HLS support. So they're going to use HLS in Primetime because that's as close to a universal format as you can get. They will support Dash, but the Dash support won't extend to iOS. So you can use HLS with Primetime to get to Android, and Primetime rebuilt the HLS stack, so the imperfect Android support that we've talked about a couple of times should be much better with Primetime than it is with the native Android support. So and Primetime is not native, it's not free, but if you're a premium content distributor, it's something that you need to consider because I think it's a good platform.
If like GW and OSMF and some other vendors are able to implement HLS in Flash, that's basically what they did, and you would expect it as long as you talk about H.264 as the MPEG Dash codec, then you should be able to develop such a player or plugin within the Flash player framework that supports Dash. So I think that's a very interesting. See if people are going to develop that. And if you bring that to the market, then it changes.
Well, actually, it changes a little bit because, and one of the points I'm going to make in a few slides. Come on, it's here. So the point of this slide is the difference between native support and what you can do with third-party applications and third-party tools like that we're talking about. So in an ideal world, you would want everything native because you don't have to buy anything else, you don't have to integrate anything else, it just works. So if you're going native, HLS is a pretty good solution because it works here and here, and all you need to do is license the JW player to make HLS work on Flash, which is still 98% of all computers. It's a very ubiquitous solution. On the other hand, if you go the apps route, and I'm saying apps very generically because there's a lot of, in America we say a lot of ways to skin a cat. Very politically incorrect for people who own cats, but so you can integrate smooth streaming with Flash now. You can integrate HLS and Dash via Primetime, not today, but by the end of the year. I think there are some vendors here who are selling toolkits that give you Dash on Android as well as Dash on the iOS platform. So I think if you want to go research and you want to go experiment and you're going to build an app anyway, then I think you can use pretty much any technology that you want. If you want to use smooth streaming, you can make it play on all platforms. The big exception as far as I know, is the OTT market. I am not sure how many of those will play Dash in the short term. All of them play HLS today. Some of them play smooth streaming today. But I don't think they're as flexible as what you have on smartphones, tablets, and computers. Anyway, I want to go back and kind of cover some things, but I think the key point of this slide was the point you were making, is that if you want to go out and find a third-party toolkit, or you want to do some OSMF development of your own, you can pretty much support any technology that you want. And again, we're covering two things right now. We're covering the encoding side, which is where we looked at the profiles, and we're going to look at some other things in a few minutes, and the packaging side. And this is all packaging. All these will take the H.264 files that you encode and deliver them to the devices that you're targeting. That means changes in manifest file format, it means changes in container format, but you use the same basic H.264 encoded files. Okay, so the bottom line for adaptive bit rate technology today, most producers are using Flash on the desktop, HLS for iOS and supported OTT devices. In the short term, I'm sorry, this should say 6 months. My short term is not 8 years. Should be, I don't see any major change to that. Midterm, 6 to 24 months. And when I did this slide a few months ago, it was 3 to 9 months, hence the terrible change. But so I think Dash is getting closer. I think we're getting closer to that being a realistic solution. But I think HLS is very interesting. That's as close as you can get to native support on all the platforms as HLS today. No toolkits, just license the JW player, and you're good to go.
So Jan, be fair though, HLS has been around since 2007, so we're 6 years in to a specification, rather than Dash, which has just materialised in the last year. So in 6 years' time, we look back at Dash and say, well, did it succeed or not? We haven't given it the fruition to come through to the market.
I am a Dash doubter, and I can point you to several URLs about that. And I guess everybody who's distributing video today cares about, what are their priorities? Computers, but computers are so easy that, that's kind of taken for granted. Apple devices, Android devices, and then OTT. So what does Dash do for me today, almost 2 years after it, was going to be the panacea? Today, nothing. And when is it going to give me Apple devices? My second biggest concern? Nobody knows.
Well, that's down to Apple. So.
Pardon?
That's down to Apple.
Agreed, but Apples are pretty damn important devices.
No, Apple's proprietary.
Sorry?
Apple's our proprietary technology. They're hardware optimized in the entire iOS ecosystem.
I hear what you're saying, but I don't really care. I mean, because I got to get video on this device or I get fired. And so until I know Dash will get me on Apple, it's just another format. Dash came out, it was a panacea. It's one format supports everywhere. And today it's nowhere. And there's no visibility at all, not even a little bit, that it will ever work on Apple devices. In fact, Adobe didn't. Never mind, not important. But I'm a Dash doubter. I'm pretty public on that. But there are Dash proponents here, and their opinions are just as valid. But if I'm trying to deliver video today, I want to deliver a cheap solution that goes everywhere. HLS works. It really does work. Okay, and the second reason I'm a Dash doubter is the whole concept of a transmuxing technology. So, bit of perspective, we've talked a while, we're saying, Flash is what you're sending into the desktop, mobile, HLS, OTT is HLS. In the past, that meant 2 different delivery workflows. Okay, so you had to encode 2 sets of files, you had to create the different manifest files as necessary. Via transmuxing, you can take one set of files and then change the container format and create the manifest files as necessary to support multiple technologies. So here's a lovely lovely graphic from Real Networks, who are here at this conference, and this shows what transmuxing does. You take one set of files in, and you can support Flash, OTT, Android, Apple, and other mobile formats via this one server. One set of files in, multiple files out, happens in real time, not re-encoding, but transmuxing. So you're changing the container format, you're creating the necessary manifest files, you're delivering those files to the HTTP server as necessary, and it's all done in real time. So why do I not think Dash is that big a panacea? Because products like this make managing different formats very much simpler. You know, it's not such a huge problem that you need a global solution. And today, Dash is just going to be another output. It's going to be another button you check on whatever streaming server you used to deliver transmuxing. And I should say, I guess I took this slide out, or maybe it's later. Pretty much every streaming server can deliver this today. So Wowza Media Server was the first one to do it with Wowza Media Server 3. They do it. Adobe Media Server does it. Microsoft does it with IIS and with Azure. And then some CDNs like Akamai also do it in midstream. So this is not a, this is a function that's proven. It's being used by a lot of different vendors. But what's interesting, if you want to transmux, you've got to have all your files in one format. So this goes back to what we talked about maybe 30 minutes ago. Are you going to encode all baseline? Because if you need to encode your OTT files using the high profile and your mobile files using the baseline profile, you can't transmux, right? You've got to create different files for the different targets. Because transmuxing doesn't re-encode, it just changes the container format and creates the manifest files. So if you want to transmux, you need one set of files that you can transmux. Okay, now let's look. This gets us back to the slide we looked at a few minutes ago. Which technologies are supported on which platforms? So here's the slide. And then, once again, the difference between native support here and what you can do with apps. Right? You can pretty much go anywhere with any format if you want to invest in the application development. If you want native support, obviously Apple is going to give you HLS, Flash, HDS. Android does HLS poorly, but it does RTSP as a single file fallback pretty effectively. So that's a lot of distributors, a lot of producers are saying, we can't use HLS because it's so faulty. Our alternatives are, we can either deliver an application via air, use Flash, or we can just drop back to a single RTSP stream. And that's what a lot of producers trying to reach the Android platform are doing. So if you're looking at the desktop, Flash 98%. You can use either Rtmp or HDS. HTML5, there's no adaptive yet. Probably won't be for 3 or 4 years, if ever. Because you still have the royalty issue. Is Mozilla going to support Dash if it involves a royalty? When do we stop caring about non-HTML5 compatible browsers? There's still 30% of the computers out there are not HTML5 compatible. When does that number get small enough that we can ignore them? Silverlight, 2 years ago I think it was a very viable solution. Now I think Microsoft is really just kind of backing away and starting to look more at both Dash and HTML5. If you don't want to do Rtmp or HDS, you can do smooth streaming via an OSMF plugin to Flash. You can do HLS via Primetime or the JW player. And then, as we talked about, there are numerous alternatives for Dash via third-party plugins. So again, if you want to go native, Rtmp and HDS is the easiest, but if you want to invest, you can use pretty much any technology you want. We're kind of running short on time, so let me take it at the end. If you're targeting Apple, HLS is obviously the natural. There's ubiquitous support. You can do Flash via air applications. You can do Smooth via a bunch of different applications. And you can also do Dash via a bunch of different libraries and toolkits. So I think all those alternatives are viable. But the easy one, supported natively, is HLS. Android is a consistent problem. You know, the native HLS support is very weak. There's a lot of aspect ratio issues, scaling issues. Good article, I think, that someone referred to from the JW website. The pain of live streaming on Android also covers kind of VOD. The easy answer that they talk about is fall back to RTSP. And again, a lot of the producers I've spoken with in the US, they kind of do the same thing because it works. You know, Android supports RTSP. It's not adaptive, but it does get a stream playing in the Android platform. If you want to invest, you can do Flash via Air applications. A lot of premium producers are doing this because it gives them, you know, one format they can send to all their players, you know, via Air applications on HLS and Android. And obviously they can use DRM, they can use captioning, everything that's supported in Flash they can do on both Android and the iOS platform. You can do HLS via Adobe Primetime. Again, that's a solution for premium producers who are monetizing their video. And then you can do Smooth and Dash via third-party tools. So I think the easy solution is RTSP with a lot of other alternatives if you want to invest the money and the time. OTT, you know, I've not heard a lot about the third-party toolkits for a lot of these platforms. The real easy answer is HLS. Smooth is supported on a couple of platforms, but HLS is pretty ubiquitous. Okay, so we've covered the delivery side. Now let's look at a couple of different, you know, how we configure our adaptive streams, how many streams, resolutions, data rates, and what H.264 parameters do we use. And then how do we change our encoding because we're encoding adaptively. Okay, and that'll take us to the end of our presentation. The big question we've asked a couple times, one set of streams for all devices, or do we customize streams for each class? This is Turner Broadcasting, their NBA League Pass. They produce these files for the web, these files for mobile, these files for OTT, and they were all different. So again, when I said a few minutes ago that Turner resisted my wisdom, you know, here's the proof. And a lot of the large networks that I haven't worked with a lot of the large networks, but the ones that I did, they produce separate streams for web, mobile, and OTT. They don't do baseline all. They do high profile for the OTT, and for the computers, they do baseline for web. What does that mean? It means they can't transmux, okay, because they're using multiple sets of files. The smaller sites that I've worked with, they tend to use one set of files, all baseline, and they do transmux. Again, you know, I would just recommend you test, you know, before you encode some main, some high, some baseline. I would pick your parameters, test, see how much difference there is, and make a decision then. Okay, how many streams and what configurations? When I do this exercise, my first concern is mobile. So my first thing I have to do is pick my mobile streams because those are the most problematic, right? You know, OTT will play anything, computers will play anything, mobile is where the problems are. This is Apple TechNote TNN or TN2224. It is one of the most useful items available on the web certainly for encoding for iOS devices, but I think it's a nice starting point for anybody who's adaptively streaming for multiple devices. This is a screen grab of their recommendations. So this is what Apple recommends for adaptive streaming, and this covers all their devices. So these are the devices they're compatible with. I would start here. I'd say looking at my mobile devices, big question, you know, how low a data rate do I want to go to? Apple says start at 200 kilobits per second. Some of my clients go as low as 100 kilobits per second because they really, you know, so you need to make the decision, you know, what do I want to support here, and then configure your video appropriately. And we'll spend a little bit more time on that in a minute or so. So focus on this first. That's your mobile. And this is a slide from, it's MTV, not HBO, excuse me. once you decide on your mobile platforms, I would focus on my web platforms, what people view in a browser. And my main concern there is that I have at least one stream for each window size, right? So if I've got a 640 by 360 window in my website, I want a 640 by 360 encoded stream. If that's the only window size that's supported, maybe I have multiple streams, maybe one at 500, one at 700, one at 900. MTV has multiple windows in their various properties, and they have one stream for each window size that's supported on their platforms. So first I look at mobile, then I make sure I have separate streams for each window size on my website. And then when I look at the OTT side, it's really more a question of cost, right? How much can I afford to send? So if my video is not being, if I'm Major League Baseball and I'm getting $20 a month, then maybe I can look at an 85 or 8.5 megabit per second stream, which probably costs Netflix 4 to 8 cents to send this per hour of video. But if you're using Brightcove and you're paying their premium rate, that can cost as much as 50 cents or $1. So you really have to look at how much this costs. It's nice to have high quality video, but you got to pay for it. So my concern here is, how low do I want to go? What streams do I want to configure? Here it's what window sizes am I supporting on the web? And here is what can I afford, because most of this is going to be shown at full screen anyway. So window size is an important consideration. How many streams do you need? At least one stream for each playback window. Typically, if you're doing SD video, you can get away with 3 or 4 streams. HD video you see is up to 11. Most websites I've worked with average maybe 7 or 8 streams for starting at 720p going down to mobile. You see more for entertainment, fewer for business, and the most for subscription, because people who are paying monthly, they want to have a good experience at every connection speed. What resolution? I would never encode it larger than source. So if I'm working with SD video, I never produce a 720 stream. I mean, that's crazy, right? It doesn't improve the quality, it increases the bandwidth and cost, but doesn't deliver a better experience. I don't want to hammer home this point too much, but the resolution should match the playback window because it gives you the best blend of quality and playback efficiency. So if you're playing back a 640 by 360 stream and a 640 by 360 window, you've got optimal quality and playability. If you scale that stream down to play, it's too much CPU overhead and it's wasted bandwidth. So encode at your window size when you can. If you can't match the playback window, it's better to scale up than to scale down. What data rates? Must be sufficiently far apart to avoid constant switching. You really want to arrive at one good data rate and kind of stay at that data rate. And it's got to make a meaningful quality difference. You don't want a difference at 640 by 360 resolution, a difference of 100 kilobits per second, nobody's going to notice. So you really want to have a 300 or 400 kilobit per second difference, because then, if you have to go to the lower quality, you have to, but you're not switching where it's not meaningful to the viewer. And this is MTV. You see their differences increase as the window sizes increase, and that just makes sense, right? 350 kilobits per second is these are mobile streams, so they're never switching from this one to this one. So the minimum difference for them is 350 kilobits per second. When I see differences in the 1 to 300 kilobit per second range, I say cut streams. You don't need this many streams. There's got to be a meaningful difference in quality. Okay, so what do we do differently for adaptive streaming than we do for single file streaming? There's 3 areas that we looked at: keyframe settings, bitrate control, and audio parameters. Keyframe interval. When I produce single file streaming, I generally use a keyframe interval of 10. When I produce for adaptive streaming, typically I use a keyframe interval of between 2 and 3. Why? Because you have to switch at a keyframe, and 10 seconds is too long if conditions change. So you want to use a shorter keyframe interval. You want to use the same interval in all in all files, and you want to typically disable scene change detection because you don't want, you need a consistent keyframe. If you say keyframe every 90 frames, you need a keyframe every 90 frames. Some encoders, if you insert a keyframe at a scene change, it will reset the keyframe setting, so you don't have a keyframe at 90 frames, you may have a keyframe at 135 frames. And so you need the consistent keyframes to switch streams effectively. If you know your encoder, so some encoders give the option, do you want to force a keyframe at 90 frames even if you had a scene change keyframe in between there? Some encoders give you that option. If you have that option, you can use the keyframe you can use the scene change detection. If not, I would disable that. And again, typically shorter, between 2 and 5 seconds. Most producers use between 2 and 3 for the keyframe interval. And then for HTTP-based technologies, the keyframe interval must divide evenly into the chunk duration. So if you have a 9-second chunks, you use a keyframe interval of 3. A lot of producers use 6-second chunks, so you'd use 3 or 2 or 1 or 6, but typically it's 2 or 3. And again, unless you know your encoding tool can force the keyframe at each breakpoint, then I would disable scene change detection. CBR versus VBR. VBR is variable bitrate encoding, gives you the highest quality because it matches the data rate to changes in stream complexity. Most white papers recommend CBR. If you look at the Adobe papers, the Akamai papers, Microsoft papers, they all say use CBR, it gives you a consistent stream. Pretty much everybody ignores them. Most people do some kind of VBR. Who's doing adaptive streaming right now? Anybody out there? Who's using CBR? Who's using VBR? Okay, so, if you look at the white papers, they all say CBR. A lot of the producers, MTV, they do 2x constrained VBR. What does constrained mean? It means you set the target data rate here, and then you use your encoding tool to constrain the maximum at maybe 125%, 150%, 200%, but never beyond that. And then with my clients, I use CBR because I really just want it to work. And if the frame quality is a little bit less, then so be it. But as you get more into it and more experience with it, it's worth trying VBR. And then, sorry about this. Again, if you look at the white papers, they say use the same audio parameters. It's interesting if you look at the Apple recommendations. The audio bitrate is 64 kilobits per second on all streams. So white papers recommend using the same audio parameters. How many people are using the same audio parameters? How many people use different audio parameters? Is that working out for you? Yeah, so I think the white papers say no, the producers say yes, and I guess the only thing I would recommend is I wouldn't change the kilohertz or the bit value. I would just jump from mono to stereo using the same. I'd go from 64 kilobits per second, 44 kilohertz, 16-bit mono to 128, 44, 16-bit stereo. I wouldn't change this from 44 to 22, and I wouldn't change this from 16 to 8. And then test, make sure that no popping occurs, which is what all the white papers warn you may occur if you do change that. I know that, if you're producing talk radio, if you're producing a talking head like this, it really doesn't matter. But if you're producing a ballet or you're producing a concert, you really do want the audio parameters to scale with the video parameters of the experience, because that audio is a big part of the experience. For some events, where for news, it's really a pretty small piece of it. Any questions? Okay.
Thanks for the talk. I have a lot of questions, but probably one related to HLS and Dash. You mentioned in the beginning about quality and so on, and then you put stuff into an Encode transport stream, which has significant overhead. So wouldn't it better use another format? that delivers higher bitrate and lower overhead. For example, using MP4.
You know, I think that's a good point. I think that's a concern. You know, your first concern is, so I guess the question, to repeat the question, is doesn't the MPEG-2 transport stream have inefficiencies that result in a higher bit rate if you use that than other technologies? So the answer is probably yes. I've never seen that quantified. It's not 50%. It might be 10%. But you have to, it's a balancing act, right? I mean, you know, HLS works. If you want to use Dash or another technology, you're going to have to pay for the plugin, pay for the development work. And, you know, if that's worth it considering the savings, then maybe you do it. But if it's not worth it, then you don't do it. But, you know, HLS, it's 6 years old, but it's still working. And again, all we really care about is making sure the video plays on this thing right here. And HLS is the only technology that makes it work today natively. So it's cheaper, it's easier, and you know, it works.
But the reason that it works on this device is not the technology reason, it's something else.
Is not what?
It's not the technology reason, it's something else. It's because Apple requires you to have HLS on iOS. If you stream more than, I don't know, 10 minutes or something like that. So it's not the technology reason from that. And I think those people who...
Well, I mean, that's like saying the only reason a TV works is because of NTSC. I mean, granted, NTSC is this old standard from 1945, but when you turn... Pardon? You're right. Sorry, bad example. But the, you know, the point is the same. I mean, I don't think nobody will argue that HLS is this wonderfully innovative technology. I mean, I think it was brilliant when it was introduced. The whole HTTP, you know, as compared to the Rtmp, is very, very cool. But you know, it works and it's native, so it's cheaper than anything else, and it's working. So I mean, it's hard to argue against that. Anything else?
What's this Dash royalty question?
So what is the Dash royalty question? Dash contains IP from various companies, and some of them want to get paid for it. So if you read, you know, I wrote a story about Dash, you know, what is Dash? It's probably 18 months old now, and one of the questions that came up was the royalty issue. And it came up because Mozilla said, we may not support it because there's IP in here and we're not sure if there's going to be a royalty or not. So nobody is talking about it. It's the great...
From a player perspective?
Yeah, well, nobody knows. Could be Encoder. Encoder's not so bad, but player, if there's...
We make a Dash player for Android. We don't have the royalties.
Well, you don't know that.
We haven't had our way. I mean,
Well, yeah, there's a lot of X264 users who are, you know, selling subscription video that aren't paying a royalty either. But you know, if they get, you know, so it's. I mean, I'm not, you know, I don't know. But again,
I'm intrigued.
it is. I mean, I asked Adobe. You can, you know, Adobe's a public company. They don't lie,
Yeah.
but they reserve for things like this. And I asked them, you know, when they announced primetime, one of the questions was, do we know anything about the royalty on Dash? And they said no. We don't know if there's going to be a royalty or not. So, I mean, it's a concern. And particularly for Mozilla, right? Because they don't like using...
Yeah, they don't use like anything that's licensed.
So, and they're the people who raised the issue. So, it's not a, you know, not a lot of people are talking about it. It's like the, you know, anyway. We're out of time, so I won't.
But Mozilla, they started to implement Dash natively. Now they switched to the media source extensions, which are already implemented in Chrome, and they support the Dash formats. And also, I mean, MP4, MPEG-2 transport stream is probably not yet implemented in the Chrome browser, but it's in the specification. So from the segment formats, you will have browsers like Chrome. I know Microsoft is also involved in that, and Mozilla now switch to that. It will come. And which manifest you use, I mean, it's a...
Yeah, this is not, any questions about, I mean, I don't want to, this is not a question, it's a debate. And I don't mind debating, just I don't want other people to have to sit and listen to it if they have...
Where do you think that Android native HTML5 support is heading towards? I mean, you say HLS is supported, not supported.
It's not supported
my
well.
experience, it works very bad for VOD especially. So
where do I think Android is going? I mean, I think they're going to do Dash. I just wish they would do it quickly, because I think that could really swing things in a big way in Dash's favor. You know, and I don't know why they wouldn't, right? Because it's a, you know, it's a public standard. So I don't know why they're not. They just haven't yet. And I think it would be really good for Dash if they did. Not so good for you, but
Why?
well, because then they would. Well, I guess it would be only perspective, but.
Well, we make SDK for different things as well as servers.
Oh, okay.
So it's not a question, I'm just going to read out something that's on the 9th of May, posted by a chap at Google, Aaron Caldwell, is implementing Chrome. He says that Opera, Firefox, IE and Chrome are all currently implementing MSE, Media Source Extension.
Okay.
That will go on Android, according to this.
Okay, so the media source extension.
Yeah, so that means you can play Dash or any of these other streaming things in JavaScript and deal with it, fire out to the video tab.
Okay, so that's Chrome.
Chrome, IE, Opera, Firefox.
Yep.
So you haven't
Okay, but that's a Google person saying it?
Yes.
Okay, I mean, I'll check that out. But I mean, I don't see, Mozilla hasn't supported H.264 yet. So they can't play H.264.
MSE is nothing about the codec, it's about the transport.
Well then, that's great. They can't play the H.264 file, but they can do something with the transport stream. I mean,
Dash covers WebM as well.
we don't even want to go there. I mean, any other questions? Yeah, I mean, any other questions? All right, thank you for your attention.